Hi, welcome to Beyond Matplotlib and Seaborn, a survey of Python data visualization tools. My name is Stephanie Kirmer, and I'm a senior data scientist at Saturn Cloud, a company making large-scale Python easy and accessible to the data community with Dask. I've worked in data science for years in a number of different fields and industries, and I've learned that we need to be able to effectively communicate with data no matter where we work. The challenges of making data visualizations with Python has been a persistent problem in the otherwise excellent PyData ecosystem. So there are some solutions that I have found to make this a lot easier, and I'm going to share them with you today. I'm going to talk about 6 Python data visualization libraries today and tell you about the strengths and weaknesses of each so that you can make an informed choice about the tool that's right for you. Here's our libraries. On the left, you'll see Matplotlib and Seaborn, 2 very well-established data visualization libraries, as well as, on the right, 4 new libraries, Boca, Plotnine, Plotly, and Altair. I say new, but these libraries aren't actually as new as you might think, and in fact, some of them have been established and working for a very long time. As I am going through these libraries, this is the criteria that I'll be using in order to evaluate which libraries are the most effective or easiest to use. A power user in any tool can probably get where they need to go with some difficulty and effort, but we're not approaching the project from that angle today. I'm trying to make an evaluation guide for a busy person, not a power user, who needs to get to good visualization quickly with not too much effort. I want a learning curve that's easy, consistent grammar, so that when you learn some basics, you can improvise on that using common sense without having to look up every piece of syntax. Flexibility, so that you can start with the defaults, but get the customizations and the specific features that you need. And really attractive output, because I think that we sometimes fall into extremes of either spending hours making plots attractive or assuming that the aesthetics don't matter or aren't important. Example might be plain white slides with plain back font that you see all over the place. I think we can find a good middle ground where really attractive plots can be created without a ton of user effort. Finally, I'm also interested in interactivity, although not too many libraries can actually produce this, so we'll talk about the 2 libraries that are in today's testing that really have interactive components. I chose these plots as my test cases for the libraries that we're evaluating. These are commonly used, and they require some different functionality, different shapes of data, different use cases. These should be familiar to data practitioners and professionals most of the time. 3D scatterplots are a slightly special case. I like to use this for PCA, but that's not really something that everyone will use, so it's not a requirement for a library to be considered high quality. However, 2 of the libraries that we're going to look at today, in fact, can do a 3D scatterplot, so I'll show you how they look. Our dataset for all of the visualizations across all the libraries is tracks from Spotify, with characteristics about each song or audio file. Includes some categorical data, numeric data, and a date field, which we'll use later. In addition to creating all these plots myself, I put the code in front of someone who knows some Python but doesn't do data visualizations to get feedback and hear questions as well, and use that to shape some of my analysis. The first library I'm going to show you is Matplotlib. This was developed initially in 2003 and was rewritten in 2008. This is a native Python library, but it emulates MATLAB syntax in a lot of places. Here you can see the gallery of output that Matplotlib was able to produce for today's tests. You'll notice that it includes 3D scatterplot. This is one of the libraries that can do that. It does not include interactive plots because that's not one of the options. Let's take a look at the code for a Matplotlib plot to see what that looks like. Here you can see the code that generates a histogram for Matplotlib. There are a few elements to this that you might notice are a little bit confusing. Most people generally have to start with copy and paste or examples to get going in Matplotlib. The syntax is not that intuitive. What is fig? What is ax? It's hard to necessarily know unless you go through and read the tutorials. You can start with relatively simple code, but it gets complicated fast when you want to make visual design changes. Using subplots, as I've done here, is almost always required for really complex layout work, and the API is not consistent with plain singular plots. Arguments in the functions have sometimes very abbreviated names. The versatility is hard to come by there. And then in one particular case, the labeling of grouped bars, I found Matplotlib exceptionally difficult to work with. Note that Matplotlib only accepts NumPy arrays, or it doesn't make any promises about the quality that you'll get out of data if you don't use NumPy arrays. So this means anything about aggregation, data grouping, and so on has to be done manually before you generate your plot. It does an okay job of handling series overlays, having multiple series one on top of the other, and letting you set those aesthetic changes. The defaults are aesthetically pretty grainy, they're not very attractive, and it takes real work to get a plot like this to look polished. So this leaves us with the report card from Matplotlib. The learning curve is not very easy. The grammar is really inconsistent in spots, it's mixed at times. The flexibility is sometimes there, but there's odd things that are really difficult to do, like labeling a group bar plot. The output, I would say, is not nearly as attractive as some of the libraries that you'll see soon, and it's not interactive. The next library we're going to talk about is Seaborn. This was developed in 2012, and it actually builds on top of Matplotlib. It adds a few things that are really nice to have, like integration with pandas, so you're no longer limited, theoretically, to NumPy arrays. And a lot of times the things you would do in Matplotlib can also be done in Seaborn, but the results might just be more attractive. You can see the gallery here of plots. I think these are more attractive default-based plots than what you see out of Matplotlib. So now let's look at some code from Seaborn. You'll notice that this uses the same subplots element that Matplotlib was using in order to design the shape of the plot. But aside from that, there's quite a few things that are clearly a little bit more easy to work with. And there's less code altogether. I also think that the histogram generated by this code is more attractive visually than what we saw from Matplotlib. One of the things that I find particularly challenging about Seaborn is that the grammar is really inconsistent at times. Once you learn to make title or label for one kind of plot in Seaborn, you're not always able to rely on that for other plots and other situations. There are some challenges with the API being unclear or inconsistent that I think are partly because of the adding on top of Matplotlib that Seaborn has to do. I also think that there's a few elements of the data manipulation required ahead of time that can be a problem. For data manipulation in multiple series overlay, you're required to actually melt your data into a single long data set, which isn't necessarily conducive to setting different aesthetics for different series. That brings us to the report card for Seaborn. I think that the learning curve is really still the same as far as the challenge to getting started. Matplotlib is difficult to get started with, and you really can't do custom complex things with Seaborn without already knowing Matplotlib. The grammar is not very consistent, and a lot of things that you might intuit or expect to be true won't be true. Flexibility and attractiveness of the output are definitely improvements over what Matplotlib has to offer. It is also not interactive. The third library we're going to look at today is Boca. This was developed in 2012 and is sponsored by NumFocus. The plots are much sharper and more attractive than what you might find in Matplotlib, and JavaScript on the back end allows this to be possible. It also makes it possible to add interactivity, but one of the downsides is that plots in Bokeh tend to load more slowly on the HTML pages or websites than other tools. Let's look at some Bokeh code. Here you can see the code that's required to create a histogram with Bokeh. You'll notice that Bokeh does not actually natively support a histogram, so instead you have to create a histogram set of parameters using NumPy, and then pass those to Bokeh to create a series of rectangles on the page. This seems like a strange oversight, and I hope that someone at Boca is working on enabling native histogram support. Aside from this, I think that Bokeh is very intuitive to work with. The grammar makes sense for almost all other kinds of plots, and the learning curve is not difficult. Here's my evaluation of Bokeh. The learning curve is easier than anything we've looked at so far. The grammar is mixed only because of the very strange issues around the histogram, and I think that the library has great flexibility, attractive output, and the interactivity is a really nice element. Now let's talk about Altair. Altair is a library that was developed in 2016. There's a group of maintainers, and it's actually based on Vega and Vega-Lite from the JavaScript. There's a really major limitation with Altair that has to be discussed before we can go on to anything else, and that's that it can't handle large data volumes. But unlike other libraries where a large data volume might create performance challenges but not create a blockage, Altair will error out at any dataset larger than 5,000 rows. You can make an override, which is a little bit complicated, and if you do this, you'll find that the performance of Altair really comes to a screeching halt. Things like group bars then are fine to build because those pre-aggregate the data, but in other kinds of plots you'll find yourself downsampling to make Altair an usable option, which is really too bad because the visuals are super crisp, really beautiful, and there are some really nice elements like default legend mapping that I think Altair has to be proud of. Now let's look at some code from Altair. Here you can see the syntax for a histogram in Altair, and it's actually incredibly intuitive and I think super easily readable. You create the initial chart object, add bar elements, add the encoding of the data, and then just make a few customizations of the aesthetics. The only thing you'll notice is that we had to downsample our data to 5,000 rows to get started. Altair also allows you to change from one visualization type to another with very minimal code changes, and you can chain together the attributes of plots or make them separate statements depending on what you feel is more readable. There's also a really interesting encoding scheme that allows you to specify series types for correct rendering using just a simple one-letter code inside the encodings that I showed you just a minute ago. One of the features that Altair offers that doesn't really make sense to me is that it will actually do automatic aggregations for you. So if you pass in your data as raw, pre-aggregated, say for this histogram that I just showed you, it will do the aggregations, but you're using up your data limitations. And so I'm not sure why anyone would actually use this. Your trade-off is that if you pre-aggregate the data yourself, you can actually potentially use all of it or more of your data than you could otherwise. This brings us to the report card for Altair. The learning curve is really easy. I think that this is an exceptionally easy library for a brand new user to get to know. And I think that the grammar is very consistent and the ability to improvise on the basics is very strong. However, I have to give it a bad mark on flexibility because the limitations of the data size really can get in the way of you being able to generate the visuals that you need in order to communicate with stakeholders. I think the output is just gorgeous. It doesn't have interactivity, which is too bad because it does have a JavaScript backend, but I don't think that's a requirement for an effective library. Our fifth library is Plotnine. This was developed in 2017, and this is really the home for R users who are switching to Python and who miss ggplot2. It's a port of ggplot2 from R into Python with as much consistency in the grammar and syntax as it possibly can have. There's no interactive output. The visuals are a little grainy, but that's because it's using Matplotlib on the backend. It abstracts away all of the Matplotlib code, but that's the reason that the aesthetics and the visuals end up looking the way they do. Now let's look at some code from Plotnine. Anyone who's looking at this who's familiar with ggplot2 will find the syntax extremely intuitive. You notice that you assign the data, use the aesthetics function for mapping data to the axes that you're interested in, and then you can set up the geoms just like you would with ggplot2. If viewers are not familiar with ggplot2, this might seem a lot more complicated, but for a lot of R users transitioning into Python, I have known a lot of complaints about the lack of data visualization options, and I think that this is a really nice way to get started without having to transfer data back and forth in order to get the R functionality that you're used to in data visualizations. This has all of the pros and cons of ggplot2 as far as the grammar is concerned. Mapping a series to an axis is really easy, but sometimes the aesthetics of a series, labeling legends and things like that can be a little more challenging. I think I'm a little biased because I have experience with ggplot2 and I'm a very big fan of it, but it is pretty popular and well-liked, so I imagine they're doing something right. So this is the overall assessment from me of Plotnine. I think that the learning curve is easy. I think it's very readable code, and if you're starting with knowledge of R or coming from the R ecosystem, I think you'll find it very, very easy. You won't have to even look up most syntax. I think the grammar is very consistent. The ggplot2 ecosystem does have a thoughtful, intuitive grammar for visualizations, and that it comes through here. It is very flexible. Changing aesthetics, customizations in that regard are all really easy, and a lot of different kinds of visualization are supported. The output attractiveness is not outstanding. I think it lacks a little bit in that regard, but if, as with most things, if you do a little bit of extra work, you can get where you need to go. And there's no interactivity in any of the plots at this point. So our final library to talk about is Plotly. This was developed in 2013 for Python. In 2012, it was JavaScript only. Not Python specific, but the port from plotly.js to Python is pretty strong. It's built on top of that JavaScript backend, which makes a lot of things possible that you can't actually achieve with some of the other visualization libraries. I think Plotly is the most excellent, outstanding visualization library for interactive and 3D visuals in Python. And Plotly, as a whole organization, has other products that you might find interesting, including Dash, but this is a free and open source product from the Plotly organization. There are a few downsides. I think that Plotly's output, as you can see on screen in this gallery, is not as attractive as it could be, but there's a ton of interactivity, which I'll show you in a moment, in the way that you can interact with plots after they've been generated can be really helpful for communicating insights. So let's look at some code from Plotly. So one thing to keep in mind is that there are really two adjacent libraries within the Plotly umbrella. There's Plotly Express, which is what you're seeing here, and Plotly Graph Objects. Express is the sort of beginner version of Plotly for Python users. It gets you started with some pretty rudimentary options. It can generate reasonable plot. As you can see, the custom ability to interact with the plot is built in, and that's really convenient. You can see the levels of the histogram without having to set any additional or specific parameters to do it. You can also use zoom and pan functions and select and things like that. But one of the things to keep in mind is that once you've used Plotly Express, that doesn't necessarily give you grammar that you can build on within Plotly Graph Objects. Plotly Graph Objects are really where you get the customization ability that you might want to generate visualizations that can be used in, say, academic or business setting, but you have to learn a new grammar in order to do it. So this is the overall assessment I make of Plotly. I don't think this learning curve is as easy as it could be. I think that the difficulty of switching between Plotly Express and Plotly Graph Objects and trying to figure out which of those things you need and when is challenging to the new user who's not necessarily sure of the lay of the land. The plots are, however, really flexible. The interactivity is outstanding. I think the aesthetics of the output really depends on what plot you're looking at. So these are the sort of recommendations that I'd make depending on what your priorities are and what visualizations you're really interested in seeing. If you want visualizations that have excellent, easy to interpret grammar and easy learning curve, I think Plotnine and Altair are really the winners in that regard. And once again, I'm always caveating Altair with the provided you don't need to plot things that are larger than 5,000 rows. Interactivity is only available in Plotly and Boca, and I think that those really are very different libraries with very different strengths, but if you need interactivity, those are the ones you want to look at. I think Altair and Boca, because of their JavaScript backends and then the way that they are built, produce the most attractive graphs and visualizations, bar none. So if the aesthetics are really your biggest priority, I would choose one of those. And then as far as flexibility, broadness of features, customization options, and things like that, Plotnine has a lot to offer because it's coming from the ggplot ecosystem where those customizations have been tried and evaluated and established over a long time. And then I think Boca also has a ton of flexibility and a ton of opportunities to get you exactly what you need. So now let's take another look at some of the code, and I want to show you some of my favorites and my sort of recommendations for the best of different categories for visualizations. So let's look at these best of winners, and I'll talk you through a little bit about why I think these are really excellent visualizations. First, I think that Plotnine makes the best histogram. There are a few reasons for that, but it's a combination of the visual quality and the ease of use. I think that building this visualization is easy to do for even the new user, and I think adding on it and making changes to it is also really easy. I don't think it's the most attractive of the histograms that we're able to generate, but I think it does a really nice job while still being incredibly simple just to get started and to get the quality that you're looking for. So second, I think that the plain scatterplot is best done in Boca, and the code is a little long because there are a number of different parameters that you set, but when you're dealing with a Bokeh plot that's not a histogram, it's really easy to get started. You design what kind of output you want, where file or notebook are really the choices that you have, and then you create your figure with few custom parameters around the design of your figure, and then you add the scatterplot element to it, and you're done. So this all is really intuitive, easy to read. Customizations that I've added to this, like color and line and transparency, are optional and certainly not required to be set in order to get a nice plot. For faceted scatterplot, I think Plotnine and Plotly are both really strong, and in this case I'm using Plotly Express for the Plotly. So here we've got faceted scatterplot from Plotnine. You'll notice that the syntax we're looking at here is very familiar from the syntax we saw for the histogram. We've added the line for facet wrap, and instead of geom histogram, we're using geom point, but otherwise a lot of the same features apply. I think that the Plotly Express faceted scatterplot is also really nice and easy to work with. You'll notice that the only thing you really have to add is a facet row, identifying the column that we're going to use to divide up our data, and beyond that, everything here is almost identical to what we would have used for a single scatterplot. However, I do think the aesthetics of the Plotnine version are better than this. I think that this is a little bit hard to use, but of course when you scroll and use interactivity, you can see a lot more detail about the individual points, which could be handy. As far as grouped bars, this is where I think Altair really shines, because we pre-aggregate our data, so we're not enforcing the limit on the data size. We can pre-aggregate it and then use this really smooth, intuitive syntax to generate our grouped bar plot. Here you'll notice that in our encoding section, X, Y, and color are each followed by a single letter code. These letter codes are telling the Altair API what kind of data to expect from these, and it's changing the visual representations accordingly. For more information about these, I will put a link in the notes at the end of the presentation for you to visit. I think Bokeh does the best job with timeline plots. Here I am doing 3 different series on the same timeline, which could be a challenge for any visualization library, but I think that Bokeh does a nice job of letting us customize the attributes of every series, and then making them all attractive and visually appealing on the page. Now, finally, I want to show you the 3D scatter plot from Plotly. This uses graph objects. This can't be generated in Plotly Express. However, the results when you actually get this working are really impressive. We start off with importing a few elements from the Plotly graph objects library. I'm downsampling here just because the 3D scatter plot looks more appealing and is easier to read at a smaller data set, so I think that makes sense. And then we set our X, Y, and Z features, and then a color element, which is going to decide the color of our points. Beyond that, I start by creating the figure. You'll notice that this syntax starts to get complicated really fast. We have nested lists going on in here, which is a little bit of a challenge, especially for a new user. Then we add the update layout element, which we remember from the Plotly Express approaches, including this new element called scene, which will give us the ability to label our axes. And then we show our plot. You'll see here that we can pivot in all directions to view our data, and that the yellow elements are explicit songs and the purple ones are not. And you can see every data point with its X, Y, and Z values by hovering. So while this is a bit of a challenging plot to generate and might take a little bit of work if you're starting from zero, the results are, I think, very impressive and worth taking a look at if you are in the market for a plot like this. So With that, I hope this has given you some insights you can use to make better choices when you next need to create a data visualization in Python. There's not one perfect library, but these new libraries offer great options that you can use to make your visualizations work better. Thank you for joining my talk today. Please feel free to visit on GitHub, on my website shown on the screen, or on Twitter, and thank you very much.